Hi, I'm Adam. This is my fifth talk. Funny enough, this is the first time I actually spoke at exactly this place. So 4 years in tech, I'm in from sport. My past talks I've given on observability, spoken at Yorkshire DevOps, eBPF. There's actually a recording of that, don't watch it. It's actually unfortunately not big. And we're a gateway, so I did the documentation for version 2. Cloud custodian, yoke. Just like contribute to any other issues that they might have. And then recently I'm an AWS community builder, mainly focusing on security. So I'm a bit of a security builder. So that's Cilium 5, and then Foundation 7, AWS 10, Cisco 16, platform engineering 4, chain guard, and currently doing Microsoft 102. I don't have a social life, that's all. No, don't. Okay. So today we're going to be talking about. I'm going to be talking about 6 things shift and left with regards to security. I'm going to explain to you what that actually means. AWS CI and CD pipeline security, Terraform, infrastructure as code security, automating infrastructure as code scanning, supply chain security, and multicloud patterns. So, why shift left? So, a shift in left basically means that you're proactive with regards to security. The traditional approach is that you're reactive, something happens, everybody starts screaming, management comes in, and then they're sorting the whole thing out, and then more screaming happens afterwards when you look at the whole cost. Shifting left basically means that you're looking at patterns in the past, and you're trying to see, okay, what are these issues that have happened in the past, let's put in some ways, policies to stop it from occurring. So I have a really good visualization of this. They have the 110, 100 rule. So software written in development early stage costs $1 roughly. The round up obviously. When it comes to QA testing, it costs $10. But then when it comes to production, it costs $100. So what they're actually saying is that during the whole process, depending on what stage you are actually in, cost of catching a bug or catching a security issue multiplies by 10. That kind of paid attention in maths. That's been awkward. Okay, so one of the popular breaches that occurred with a supply chain attack was a SolarWinds. It's a supply chain attack. Basically, in its simplest form is if everybody's drinking from the same water part or same well, and someone defecates in it, and everybody drinks from it, that's a supply chain attack, basically. Like you're not directly involved in the breach, but indirectly you are. You're indirectly affected by it. So people who are using SolarWinds were all affected by it. 18,000 organizations. It took 9 months to fix, and it took a whopping 100 million to fix the whole thing. That's just like walking around for me, I'm joking. You can learn from it. It's totally. So, DevOps mindset change. So, when I said shifted left, it's not only just about management or just about senior members of the team being involved with regards to security. It's everybody. So, people not hard coding. The API keys into GitHub actually do that. It's fun for me. Yay, free resources, nice. I'm joking. So be proactive, collaborative, continuous learning, continuous development. So you're always looking at what's out there, but just because something's the latest new feature or the latest new product, that doesn't mean you have to incorporate it. If it works for you, it works for you. But yeah, plugins using pre-commit hooks. CI checks and production monitoring, so after the whole thing's been issued. AWS and LA. So source code, so pull request review. So pull request review before merging to the main one. Basically having someone that approves it and having someone else to approve that also. I don't know why people do that these days. Sign commits, using code owners for files, and then reviews for security team for sensitive files, automatically assign reviews based on file paths, and here's so code goes by AWS. One thing you can do with them, you can isolate the whole production, or you can isolate an application, you can test it out, see if it works, see if it doesn't. There's no public attack surface. The traffic is controlled by security groups, access by VPC endpoints only. It's only reasonable. I built up after the signings, and then that space. Okay, deploy stages. So basically, when it comes to IAM roles, make sure you're not using wildcards, you're actually using least privilege. Everything, if you think of least privilege, everything's been breached. So you just don't fine-tuning everything to the last thing. Deploy verification, smoke test, post-development, security validation checks, health checks, and metrics and monitoring. Using blue and green methods, and using canary method also. You can Google that, anybody's not familiar. Then Terraform and infrastructure code security. So by default, Terraform, when you create a state file, it's a local. It's pretty much the heart of the whole infrastructure. So basically, it means that anybody can see it who has access to your laptop or your tablet or your phone, if you're one of those people. Basically, nerd. So with Terraform, you can actually upload it to S3 bucket. The thing with S3 buckets, they can be also breached, and there have been a lot of cases of S3 buckets being breached. A lot of times what happens is like, the company does it and like, okay, fine, we learn from it. Then 2 years later it happens again, and we're like, nice. So backend configuration, the S3 bucket, the name has to be globally unique. The key is in a prod. Region US is one, obviously, that's what it be. Encryption is on, and KMS keys, AWS will manage those, I think, I hope. So, yeah. Then when it comes to state locking, you can enable it using dynamic DB tables. With regards to all of this stuff, cost needs to be taken into consideration, and management approval also. I don't know why, but that goes on. Provider credentials and secret management. So never enable AWS keys, passwords, or tokens in Terraform code. Use a secret manager. A lot of this stuff is really basic, but you'd be surprised at how many people actually don't do this. Again, common sense is not so common. So automating ISC scanning. So I am aware of what happened with these guys that had a breach recently. But it was lightning fast. Terraform scanners, comprehensive pulse code scanners, built-in compliance benchmarking for organizational governance, and TF edit for Terraform caching. And then CI integration strategies for enforcement. So run all three tools on every GitHub action. It can be time consuming, but in the long, you're just doing all the heavy working now, all the heavy lifting now, so later on you can have benefits of it. So enforcement strategies, built-in, enforce, prevent, and then severity thresholds, critical, high, medium, and low. One of these is just to make sure that nothing that should go, that's not sensitive, is out. And then security. So the next supply chain security, Docker container and TUF, they're being pretty much gone. So real-time protection, offline storage, prevent online attacks, key rotation, role separation, not giving everybody access to everything at the intern, except for if it's me, then give me everything. Joking. CF role hierarchy. So, yeah. And then the new modern approach is sys, stores and cosign. CI example would be sign of builds, keyless signing, so basically make sure that you don't have keys that are stored forever, they're rotated. Then you can see over there from 2024 to 2025 growth that has occurred. Sign SIM store components. So, yeah. And then supply chain levels of artifacts, provides manual models for build security with 4 progressive levels. So you've got the basic, you've got sign, and you've got harden, and then you've got connected builds. And then multicloud security patterns. So zero trust basically is saying that everything's breached. Good way to live also. A lot of times when you buy a product, it allows like inbound traffic, and inbound traffic is allowed, especially which shouldn't be allowed, especially if you have something that's very sensitive. It should be isolated and then tightly monitored and tightly everything. Those who have access to it should only have access to it because they need it, not because just for the sake of having access to it. So, and then you've got policy as code. So using something like OPA, which is open source project, it uses Rigo, which is a generic policy engine. You can pretty much tailor it to what you want. Then you can use something like a central log monitoring system like Splunk, Datadog, or Chronicle for one, so you can see everything in one pane of glass. So no public S3 buckets or storage accounts, mandatory encryption, rest and in transit, requires labels for cost allocation, and in containers, images must be signed. And this is the key takeaway of the whole story. That's it. Any questions?
Thank you very much.